Our first speaker this morning is Bruce Hayes on Milton, Maxent, and the Russian method.
Thanks, Diana. Well, this starts the metrics portion of the program. So let me start by reading from a kind of urtext of generative metrics, Halle and Kaiser, 71. When a poet composes metrical verse, he imposes certain constraints upon his choice of words and phrases which ordinary language does not normally obey. The poet and his readers may not be able to formulate explicitly the nature of the constraints that are operative in a given poem. There's little doubt, however, that neither the poet nor the experienced reader would find great difficulty in distinguishing wildly unmetrical lines from lines that are straightforwardly metrical. Which I think defines the research problem really well. This is so characteristic of generative grammar across the board. The native speaker has the intuitions, has the behavior, cannot consciously explicate them, and that's our job through analysis and some kind of formal rule system. So they called for generative grammarians to rise to the challenge in this way. What makes the challenge harder, especially in the case of English metrics, is that metricality is quite plainly a gradient. We find perfectly canonical lines, lines that are complex to varying degrees, and unmetrical lines. And Halle and Kaiser give an example of this sort in the same work. The sequence Ode to the West Wind by Percy Bysshe Shelley, they claim to be an unmetrical line of iambic pentameter, and I agree. O wild west wind, thou breath of autumn's being, is metrical but somewhat complex. And something like the curfew tolls the knell of parting day is straightforwardly metrical. Gradients makes extra work for the linguist doing the analysis in some kind of idealized system where everything is either perfect or word salad. We could just render an up or down decision on everything. But such idealized systems are rare at best and certainly are never observed for English iambic pentameter. In light of this, how should we proceed? Well, I think Halle and Kaiser had a very good idea, what we might call the frequency hypothesis, which again, from the same book, the more complex the line in terms of the analysis, the less frequently it occurs. I would regard this as a hypothesis about poets, that you could regard the poet as a kind of stochastic device who outputs lines of pentameter whose frequency distribution in the long run reflects the complexity intuitions of the poet. I also have the hunch that at some level the frequency hypothesis is true. And the reason I have this hunch is that my own experience in putting together grammars intended to match frequency of the poet's output roughly match my own native speaker intuitions, such as they are for iambic pentameter. Sooner or later, of course, we want to take this hypothesis and test it rigorously, and the way to do that would be to look at living poets. But for now, for just the purpose of this talk, let's assume it's right, and it has an important consequence, namely that we can investigate metrical complexity using frequency as a proxy. Okay, so let's plunge in and do this a little bit. And here, following Halle and Kaiser's analysis of Beowulf, again the same book. Beowulf is composed in lines. Each line consists of two half-lines. The half-lines contain alliterating S positions and non-alliterating W positions. And the data that Morris and Jay analyzed back then was gathered by a Brandeis grad student now at William & Mary named Anne Reed. And she went through all of Beowulf and counted up all the types, sorted them by first half line, second half line, reaching the table that you see in 6. And the question is, how can we make sense of this quantitative pattern? The strategy that Halle and Kaiser set up was first to have some hard constraints that are never violated in attested forms, and then add some soft constraints which are violable but at the cost of increased metrical complexity, and thus, by our hypothesis, we would expect violations to be less frequent. The hard constraints are under 8. A line must be two half-lines. A half-line can have one or two positions. Sorry, the first half-line can have one or two positions. Second half-line is a position followed by a W, and that X, an intermediate constituent, can be realized either as S, SW, or WS. Lastly, you cannot let both X's in a half-line branch. In other words, there's a maximal population limit of 3. If you work out on paper what is legal under these hard constraints, you get the list in 9. And let's, for present purposes, follow Halle and Kaiser and consider only the candidates that respect the hard constraints, namely the ones, the hard constraints, the half-lines in 9, put them together freely, and you get the space of possible lines given in the table of 6. Well, now the soft constraints. To warn you, I'm going to do a little bit of framework shift. I am stating these things as constraints, but in fact, in the original, they're kind of stated as licenses. But we'll need to do it as constraints for a reason just to be given shortly. The soft constraints are star branching X in the first half line, and then star short half line, one consisting of just one position. Moreover, having played with the data, I would like to add in 2 additional soft constraints: disfavor lines where X branches as WS, and star branching X anywhere, not just in the first half line. So that's the grammar, the hard constraints, the soft constraints. How do we evaluate it? In 1971, Halle-Kaiser followed a rigorous qualitative strategy. Any relative differences in constraint violation, all else being equal, should be reflected by differences in frequency. And they do this very carefully. Today, 42 years later, we have mathematical and computational tools that let us aim for as precise a quantitative match as we can achieve. And let me talk about that now. The plan is to do a Maxent grammar, a little Maxent grammar for this case, and I need to give you a quick summary. Maxent is a kind of harmonic grammar. Its architecture is essentially identical to optimality theory. However, the constraints are not ranked, but bear weights, which are non-negative real numbers. The output of the grammar is not one single winner, as in OT, but rather a probability distribution over the candidates. The way this is done involves simple math, basically just exponentiation, division, and so on. And if you want to see what was meant to be a reader-friendly presentation, look at Hayes and Wilson, 2008. And indeed, following that work, which studied phonological phonotactics, we're going to model well-formedness as probability. Now, how does this connect to the frequency hypothesis? The beautiful thing about Maxent is that it comes with a learning procedure that is guaranteed by mathematical proof to find, in a certain sense, the optimal fit to whatever data you give it. So what you can do in this kind of analysis is put all the data into some kind of electronic form in which you have all the candidates, all of their frequencies, all of your constraints, all of your violations. And there's software, for instance, the Maxent grammar tool by Wilson and George that will swiftly compute the constraints that give you the most accurate grammar. So what it does is, of course, is to try to match the frequencies in the data corpus, which, if the frequency hypothesis is correct, is going to match with metricality. All right, adapting Maxent to the problems of metrics, we can use a method that I'll call the full string set. Let the input just be one single dummy form, call it input, and let the candidate set be, let us say, the full string set, all conceivable lines the poet might compose. In this case, all conceivable sequences of S and W bracketed by X, of which 9 are examples. So we want to find a grammar that assigns near zero probabilities to the unattested members of the full string set, assigns frequency matching probabilities to the attested members. Let's take this and do it for Old English. And following Halle-Kaiser, we'll do a shortcut. We give the hard constraints infinite weights so that candidates violating them are assigned zero probability, and we can throw them out henceforth. Focusing now on the candidates in 6, I put them all into a spreadsheet, put in the constraints, put in the violations, ran the software, and it gives you the weights top of page 5, which could be taken intuitively to be a measure of the strength of the constraints. And once you have the grammar, of course, you can compute the predicted probabilities, which I did, and you can check how well you're doing, namely, what is the matchup with the predicted probabilities of the observed ones. That's in a scattergram, middle of page 5. You can see the correlation is 0.87, which is not bad, and the scattergram looks decent, if not wonderful. Okay, so we seem to be doing reasonably okay with the Halle-Kaiser data. So, summing up so far, I've given you the concepts of metricality, gradient metricality, the frequency hypothesis, letting us model metricality with frequency as a proxy, and finally, Maxent grammars as a tool for doing this explicitly with the actual numbers. Turning to iambic pentameter, I'm going to rely to a fair degree on a paper by myself, Colin Wilson, and Ann Schisko published last year. Just like what I've been talking about, we assumed the frequency hypothesis and used it to study metricality. Our focus was Shakespeare's sonnets and books 9 and 10 of Paradise Lost. And to study them, we set up a kind of ad hoc representational system involving 4 levels of stress, 5 levels of phrasing, hence 20 possible symbols. With 20 symbols, the full string set gets quite large. For a 10-syllable string, there's going to be 20 to the 10th, or about 10 trillion. And this was handled by Colin wrote wonderful, complicated software using finite state machines that could search this very large set without bogging down. For the constraints, we set up a system of 87 constraints that we called universal metrics, based on a general conception of metrics, but intended to be broad enough to encompass most of the research literature in traditional and generative metrics. So as you can see, we borrowed in our 87 constraint system, we borrowed constraints from sources ranging over 100 years of research. The procedure was just like with the Beowulf. The software finds constraints and weights that best match the frequencies of the data, including 0 frequency for the unattested members of the full string set. And they served as a grammar, and we applied the grammar to assign predicted values to the lines in the corpus. Well, did it work? Well, to some extent, that's kind of a subjective question. I would say that the predictions of the grammar on the whole satisfy me to a fair degree as matching my own sense of metricality in this verse. And indeed, you can check yourself if you like. We did other tests, like the Human's word order repair test. So it seems to be doing, I would say, hardly perfectly. There's a lot of room for progress, but I think it's doing reasonably well. Moreover, we use this as a way of reflecting on what's been proposed in the metrics literature, and this I found kind of gratifying, that quite a bit of what has been proposed by metrics got confirmed by our Maxent analysis. In other words, it was providing the constraints that we needed to handle the data. Okay. Well, what's new in this talk? What's new is a doubt that arose during the preparation of Hayes, Wilson, and Schisko, something that was sort of like an itch that I wanted to scratch, and I thought that this conference would be an excellent opportunity to give it a try. The thing is that picking out the metrical lines from the full string set is not the only plausible conceptualization of how metrics works. It is very often the case that when you're looking at frequencies, what you want to compare them with is not just the raw frequencies, but the frequencies that you would expect or calculate as some kind of good a priori estimate. Now, what might that be here? The fact is that English utterances have their own characteristic statistical properties. For instance, it is known that they tend to avoid phonological clash and lapse. Right? So this leads to the possibility, maybe looking at the full string set is the wrong comparison. maybe we should be looking at some kind of baseline that tells us what English phonology is like in general. And that leads me to the Russian method. In one variant of the Russian method that I'll explore here, you gather a prose sample, ideally written by the poet himself, and that serves as your baseline for comparison with verse. So for instance, you might find a set of sentences that happen to be 10 syllables long. It's called the Russian method because quite a few Russians, including some very distinguished ones, were involved in setting it up. But of course, it's not just Russians. Various people on this side of the Iron Curtain, including, in fact, Kevin Ryan is not 3 hours from now. That's an old conference program. He is next, so you'll hear what Kevin does with it. You are? Okay. All right. STET. So Maxent is a formal framework for applying the Russian method. The way I propose to do it is you make a grammar whose sole purpose is to make a binary guess about whether a given line is verse or prose. Right? So if it has a very high probability for verse, we interpret that as highly metrical. Very low probability for verse, we interpret that as essentially unmetrical. We can use the very same constraints that Hayes-Wilson-Gisco did. Bear in mind, of course, that every once in a while a prose line is going to be metrical by accident, but it turns out there's few enough of them that I don't think we have to worry about that. I'd like to emphasize that I am taking the Russian method versus the full string set method, not as methodologies, but let's take them as theories about verse composition. Under the full string set hypothesis, verse composition is the selection of strings that stand out from the full string set as metrical. Under the Russian hypothesis, it's the selection of strings that stand out from the population of characteristic phonological utterances in the language as metrically probable. So those are two quite different things, and we can compare them. So finally, that leads us to my Milton by Russian method project. As you could imagine, I simply recycled the corpus of Milton verse that we did in the earlier paper, the 2,000 or so lines, and I recycled my prosodic transcriptions for stress and phrasing. What about a prose sample? Well, it turns out that John Milton wrote a huge amount of prose, and it being 2013, it's quite easy to grab it online, download it. I broke it up into sentences, randomized the sentences, and then sought pseudo-lines with the following procedure. For each sentence, if the first 10 syllables ended in a word break, I let that be my line. Otherwise, if the first 11 syllables ended in a word break, I let that be my line. And otherwise, I just didn't bother and moved on to the next sentence. Working in this way, I grabbed a prose sample, of which, as of about a week ago, I had succeeded in the rather tedious task of prosodically annotating. So I have 1,000 lines to work with. So just to see what, they're kind of dull. They're all about the history of England in the Old English times. There's his paper about divorce. They're all kind of, I don't know. At any rate, you look at this stuff, and it's quite plainly very different from verse. Look at the so-called stress profile in 31. The verse forms a nice kind of 5-toothed comb with a high peak in 10, which is just what we expect. The prose is mostly flat, but with a curious kind of low position at the very beginning of the line, which I'll return to later. Okay, now the Maxent analysis. As I said, we're modeling a binary choice, so like we could say that verse is 1 and prose is 0. For this kind of Maxent, you don't even need fancy software. It turns out that Maxent with 2 candidates is just a notational variant of logistic regression, a standard statistical procedure. So I just use the same statistics program every other linguist uses, R, and ground out the answer with R. For both methods, I used a grammar that was produced by bottom-up search. You start with a null grammar and iterate searching, at each stage finding the constraint that best improves the performance of the grammar that you've got so far. All right. Well, as a kind of sanity check, did it work at all? Is the Russian method grammar effective at separating verse from prose? Well, one way to do that is to take your output file and sort it in the following way. Put the prose first, the verse second, and then take the predicted probability as verse and sort it, what did I do? Sorted it descending. And you get the graph at the top of page 9, which I take to be quite reassuring. That is, you can see that most of the prose lines are getting probabilities close to 0, and most of the verse lines are getting probabilities close to 1. So it is indeed separating the two reasonably well. One might ask whether the full string set method does this also. So the comparable graph is in 34. And I find this also reassuring. It's not quite as good a separation, but on the other hand, it wasn't designed to separate in the first place. Okay. So, so far so good. We have a Maxent grammar intended to distinguish verse from prose in my sample. And now I have to tell you how it all came out. I should emphasize that before I started the project, I hadn't the faintest idea what I would find. Okay? I just thought it would be sort of a good, careful thing to give it a try. So here's what I found. The two methods give startlingly different results. Okay? So if you take, for instance, the harmony values, which are computed by both as part of the computation of probability, the correlation between probabilities, between harmony values is 0.17, which is pathetic. Even if you try to massage the data as I did, you can fit the harmony values of the full string set method to a logistic curve. That improves things, but R goes up only to 0.33. So the two methods are getting quite different results. And we can flip the page. Oh, yes, sorry, top of page 10. There's your scattergram plotting the predictions of the two for all of the real lines in the actual Milton corpus. And you can see this is not a nice scattergram. Nice scattergrams, of course, look like snakes. Right? So, given that the two methods are differing sharply, we can ask which one is actually doing better, which is more accurate. So the way I did this was to do another sort with a spreadsheet and look for the cases of maximal difference. Okay? So here we're looking at the cases where the full string set method likes the line a lot, and the Russian method doesn't like it very much, or vice versa. So I look at the sort and looked at lines at both ends of the sort embodying these particular kind of contentious cases. And I have to admit, I picked ones, perhaps unconsciously to make a point. So if you want to look at it yourself, I want to be honest about this. Feel free to download the predictions from my website at the place noted. At any rate, here we go. Here's the comparison. Some lines that the full string set method thinks are simple and the Russian method thinks are complex, and I'll read them to you. Where tigress at the foot of paradise, in offices of love how we may lighten, wouldst thou admit for his contempt of thee, yet are but dim, shall perfectly be then. Okay, so those are ones that the full string set method thinks are good. The ones that go the other way around, fooled and beguiled by him thou, I by thee. Out of my sight, thou serpent, that name best, one heart, one soul in both, whereof good proof, thrones, dominations, princedoms, virtues, powers. Okay, so my own take on this is that the first batch of lines are pretty darn straightforward as iambic pentameter, and the second batch of 4 lines are, though metrical, rather complex. I got at least one nod from an informed reader, from an experienced reader. Okay. So that I believe is fairly characteristic, that it's the full string set method that's getting more accurate results. We can also be a little bit more concrete about how the methods are doing. If you look amongst the favorite lines of the Russian method grammar, you will find that they include a fair number of lines that begin with an inversion being a phonological trochee placed in metrical iambic position. Moreover, a lot of these are so-called lexical inversions, where the two syllables of the inversion are in the same word. Hence, lines like bitter ere long back on itself recoils, or motion each act one audience ere the tongue. I think this is almost certainly an error for the Russian method, that you could find, I suspect, a near consensus among metrists that inversion in iambic pentameter is a source of complexity, even when it occurs in the first foot, which is the place where it by far occurs most often. And I can give you a little argument for this. A little argument for this based on two comparable systems, English and Russian. German and Russian iambic pentameter resemble English in many ways, but they're stricter. And in both of those traditions, the mainstream of verse composition avoids lexical inversions entirely. Okay, someone could take this indirectly as an argument that they're probably metrically complex even in English. Okay, so that is a kind of concrete error that the Russian method is making. And here comes this, I warn you, this part of the talk is a little bit clotted. This is my attempt to diagnose where it went wrong. Okay, so this is conjecture, but I think this might be where it's going wrong. If you take a peek at the graph in 31 again, I'm not sure whether you actually want to do that, or maybe I just gesture. 31 has amount stressed. Look up, I'm gesturing. And it goes, okay. So it has a little valley in the very first position. And we might wonder, why is there a valley there? The reason is, I suspect, syntactic. English sentences typically begin with a proclitic, like and or he or the. And so with statistically greater than chance frequency, I'm sure, the sentences tend to begin stressless. Now, of course, if sentences that begin with stressless syllables are overrepresented, sentences that begin with stress syllables are necessarily going to be underrepresented. And that in turn implies that inversions are going to be underrepresented at the beginning of the lines of the prose sample. Now, what about verse? Well, Milton is indeed an English poet, and he follows the English tradition. The great majority of his inversions are indeed in the first foot. Put these two together and put them on a graph. And you can see this top of page 12. Because of these two trends that I just mentioned, the prose sample and Milton's verse actually converge in the first position. So as far as the grammar goes, and I don't have the argument complete because I can't see the constraints that are doing this, at least not yet. But as far as the grammar goes, it seems that the first foot is perfectly fine. It's already matching what the language has, so there is no need for constraint weighting to establish any kind of deviation from the prose. Which in turn casts doubt, I suspect, on the whole idea that prose norms serve as baselines for metricality. All right, that's the first concrete argument. The second one involves the presence of big phonological breaks in the middle of the line, things like what Lisa Selkirk would call an intonational phrase break, or that sort of thing. Now, it's widely felt that large breaks in the middle of the line contribute to metrical complexity. And indeed, the lines that I read to you earlier from 38 that were intended to intuitively impugn the Russian method, I think they typically do sound bad because they have so many internal breaks, like, thrones, powers, and so on. Well, what are the numbers? And I was puzzled by this until finally I modified my little spreadsheet and just looked at the frequency, the raw frequency of violations, and discovered a sort of surprising fact. Milton's verse is richer in line internal phrase breaks than his prose. Okay. The prose, in fact, often has really long, enthusiastic sentences that go on forever, long strings of proclitics, so there's nary a stress in sight. So that it's different in its own way. But the result is that there's quite a large difference in the frequency of internal breaks in the two corpora. The result, then, is that, how do I say this? Internal breaks in verse are actually overrepresented relative to prose, and that means that the learning system is not going to assign weights that penalize them. Okay. Whereas, if you go to the full string set method, the expected number of intonational phrase breaks in the middle of the line is actually quite high. It calculates at 1.8. So in fact, it's sensible to penalize them. The system does, and I think that's getting the right results. Here again, the full string set is providing the right backdrop for evaluating the constraints. Milton's prose does not. All right, so summing up the talk, the idea was to evaluate two hypotheses. One is that verse composition is selection of strings that stand out from the full string set as metrical. The other, selection of strings that stand out from the population of characteristic phonological utterances. And so far, rather to my surprise really, the full string set hypothesis seems to be getting a better approximation to metrical well-formedness intuitions. The great big question, of course, with which I will conclude, is whether this is itself sufficient reason to reject the Russian hypothesis or it simply reflects errors in my implementation of it. Thank you.
So I have a question about a kind of principal difference between them. If you look at the examples from Milton that you gave in 37 and 38, what's striking me as a source of complexity in the second half isn't necessarily that they are involving more internal line breaks, but the actual placement of them relative to where I would expect if you assumed a template that involved higher level grouping and gave you colon boundaries that were expected in certain places. The issue seems to actually be where they're occurring in places that wouldn't be aligned with those boundaries. So they're not after the fourth position, they're not after the sixth position, they're in strange places with regard to that, so they're creating tension. So it strikes me that that seems to be something that your previous method actually can account for if you make certain assumptions about the constraints in a way that the Russian comparisons with prose simply can't, because it's not a matter of frequency. I don't see how the sentence level design in the Russian method could do that, or is there a way it could?
I mean, your point is beautiful, right? I mean, the placement of the breaks within the line is very systematic. The fundamental trends are that you like to put a break after 4 or 6, which is the colon boundary. You really dislike putting a break after 1 or 9, dividing the line unevenly. And the constraint set mostly is handling this. So there were, in the UM, the 87 constraints, there were constraints that said don't split the line 1-9 and 9-1, and indeed, using the full string method, these actually get decent weights and play a role in predicting metricality. Alas, we could not do COLA, so that part is still missing. So I would say, I think I've got your question covered, or mostly covered, because those structural principles about where you put breaks were there in the UM that the Russian method was free to sample from, but it chose not to do it. Yeah.
So one old idea about verse is that, about meter verse, is that it's not the opposite of prose rhythm, but a sort of enhancement or set something up so it says verse has to be as much different from prose as possible, it doesn't work as well as something that says verse should be as much different from random stuff as possible.
I would agree with that, that if this is on the right track, then the poet is sort of opportunistically, to put it a slightly different way, the poet is opportunistic in taking advantage of the phonological patterns present in the language to manifest a rhythmic pattern. Yeah.
I think there's a more a priori argument for the Russian method, which you haven't emphasized, and actually, I think works against the point you just made, which is that as metrists, we're building models of meters. And if we build into those models all the sorts of constraints that you also see working in prose, that is, in the general phonology of the language, there's going to be a massive amount of duplication between the meter grammar and the generic linguistic grammar. So that's really an argument that in modeling a meter, you want to model precisely the ways in which the meter deviates from the baseline that the phonology gives you. And the inversion case that you talked about is precisely this kind of example where if it's no different from the prose whatsoever, there's no reason to build it into the model. And then when you say your intuition is that that's wrong because inversion should be marked, well, that's not really, I don't know where you're getting that intuition, or maybe Milton didn't have that intuition if he didn't have any difference.
Yes, the funny part is that my scientific conscience is all on the side of the Russian method because it seems somehow much more careful and rigorous. I do believe in controlling for things. So to the extent that I'm opting for the full string method, it's only guided by what I take to be empirical facts. And your remark that you think that initial inversion is just fine is, of course, disturbing to me because I know that our data on metricality at an intuitive level is just so flimsy, and what really has to happen somehow is collection of more serious data. Sooner or later, I may start a poll of metrists. Who's qualified to make metrical judgments? I don't know, but people who've read the verse a lot. So I feel perturbed in just the way that your question points out. That's all I can say. Yeah, Nigel.
Nigel Fab. Bruce, you're assuming that the unit over which complexity is measured is the line. And I want to suggest a way of, which I'm happy with, but I want to suggest a way of rescuing the Russian method. If you were to take a unit of complexity as, say, a certain kind of prosodic phrase, let's say between say, major punctuation marks, you could measure that for verse. I mean, you could check each stretch of verse for its complexity, but then the comparison with prose would be different, right? I mean, you wouldn't get a lot of these effects showing up if you were to compare effectively the same unit in prose and in verse.
I had never thought of that, like looking at the linguistic units in the verse.
Because I guess the thing about Milton is, Milton in particular problematizes the line. I mean, he places his punctuation marks in the middle of the line, not the end. Yeah. And that's why Johnson thought that he was writing prose, right? Yeah.
Okay, actually, there's something that I could probably usefully tell you. We're, of course, familiar with this idea that Milton writes in verse paragraphs, that the backdrop for Milton is the breaks at the end of the line are strikingly weak statistically compared to other poets, and the breaks in the middle of the line are rather strong compared to other poets. So that's what gives rise to this idea of verse paragraph. The way we handled that was a little bit ad hoc, but in the spreadsheet with the data, each line had a little pseudo marker at the beginning, which indicated the phrasing, the phrase break found at the end of the previous line, right? And so we did have some sense of how line division was being statistically regulated. And in fact, when I made the prose sample, I just did this in an arbitrary way. I again imagined that the prose sample was one dreadful 1,000-line poem and copied over the junctures. So to some extent, we do have this, to some extent, we are looking at whole poems, in a sense, rather than just individual lines. Yeah. Alan?
Yes, looking at your sample here, it seems like one might ask what the Russian method, as you've implemented, is detecting, because it seems to be clearly detecting something. So if comparing 37 and 38, to pick up the example that Kristen looked at, the ones in 37 indicate that Milton knows the basics of iambic verse, like Joyce Kilmer, and the ones in 38 impress you immediately with the thought, this man is a genius, right? Okay, so something real has been detected here. And I'm not sure that this kind of very loose notion of metricality that you're using, but haven't really articulated in great detail, is the right notion to be using. So it could well be that we need more data. We also need to be thinking more about what we are detecting in the structures by these various methods.
I see your point, but I think I would want to interpret it differently. I mean, first of all, I love those lines, right? They're marvelous in context, and they just seethe with feeling, and they are not the only case where Milton has a rather complex line occurring at a really vivid point in the plot. Perhaps the most famous is where Adam concludes this long soliloquy describing in every conceivable way how he is the unhappiest person there ever will be, and says that he is miserable beyond all past example and future. So, yeah, surely this is part of Milton's art. But the point... The method. Look, but I'm not quite done. I think Milton was, to some degree, a stochastic device sampling from the probability distribution over strings, but he was also really smart. And come on, listen up, Alan. He is strategically deploying complex lines for expressive purposes. But if he used lines that were that complex 100% of the time, the verse would break down and would not be perceived as verse by us. There has to be a certain number of Joyce Kilmer-like lines to establish the norm against which the others are surprising.
Yes, but it appears that the ideology of the Russian method is it should be as far from prose as possible. So this is going to detect these cases. And you're using that to detect metricality, but it's detecting some extreme difference from prose. And the fact that someone could manage that in the verse frame is what is so striking about it. But putting aside the striking part, I still am looking for another question, which is trying to look afresh at the methods and say, what are they finding? Because they are both finding something.
I've just seen a 0-minute sign. Can we continue? I would love to continue, but maybe with a chance of back and forth. Yeah. No, I mean, I can't answer your second question, so I'd like to talk with you about it.